Hi students, welcome back. Today in this video session we will learn about hybridization of nitrogen in NH3 molecule, which is covalent compound, which is covalent molecule, also known as ammonia, So what about the valence electrons of nitrogen and how that valence electrons are involving in a chemical bonding, and what about the hybridization of nitrogen, that we will discuss in this video session. So let's begin. Hybridization of ammonia. So what about the molecular formula? It's NH3 molecular formula. So nitrogen having three covalent bonds with three hydrogens, So simply here, coming to nitrogen, which is having 7 atomic number, so electron configuration become 1s2, here 2s2, 2p3, 1s2, 2s2, 2p3. so this is inner shell and this is the last shell, which is called Valency shell, So this Valency shell having total 5 electrons as 2s2, 2p3, so I am just representing here. This is a lone pair, which is s orbital, and here we have 3 subshells which are p orbital. Here 2s2, which is as a pair. Now here px, now here py, this is pz. We have 3 electrons in p orbital existing as unpairs. We know here the covalent bond always exists between non-metal to non-metal due to overlapping of their valency unpair orbitals. So now nitrogen shows 3 valency unpair orbitals. So each unpair orbital is going to overlap with a unpair orbital of hydrogen, that is called hybridization. See here, hydrogen atomic number is 1, configuration become 1s1, so this unpair orbital is going to overlap with this unpair orbital. Simply here unpair, which is 1s1 of one hydrogen. Next another unpair, that is 1s1 of next hydrogen. Next unpair orbital, s orbital, it's become 1s1 of third hydrogen. We know covalent bond, due to similar electronegativity, non-metals, they involves in a covalent bond. What is covalent bond? Simply sharing of 1 electron. How they are sharing their 1 electron? Simply px unpair orbital is going to overlap with a s orbital, unpair orbital, which is unpair orbital, become paired. So this is mixing of valency unpair orbitals. Gives a strong bond called hybridization. So due to this mixing, here we got a one covalent bond, which is called sigma bond. In same way, py unpair orbital is overlapping with s1 unpair orbital, that is s unpair orbital of hydrogen. We are getting another sigma bond. Now here pz with s orbital of unpair s orbital of hydrogen. We are getting third sigma bond. Like now see here, nitrogen shows 5 valence electrons. After hybridization, after involving in a overlapping, getting another 3 electrons. Like now see nitrogen, which is lone pair, and we have 3 unpairs. I'm just representing here. These 3 unpairs are overlapping with another 3 unpairs, making covalent bonds. So now around the nitrogen 2, 4, 6, 8, getting 8 electrons. So it's satisfying octet rule. Like nitrogen making 3 covalent bonds with 3 hydrogens with one lone pair. So what about the hybridization here? See here, valence electrons out of 5, 2 are existing as lone pairs, that means hybridized, and remaining 3 are overlapping with another 3 unpairs. So these are hybridized due to making covalent bonds. So total S, px, py, pz. So total around the nitrogen we have 1 lone pair plus 3 bond pairs, that is equal to 4. Total 4 hybridized orbitals one is lone pair and one is bond pair. So what about the geometry? Geometry is trigonal pyramidal. So why this geometry, why we are getting this geometry? So this geometry due to Valency Shell electron pair repulsion theory. According to Valency Shell electron pair repulsion theory, when the element shows lone pairs as well bond pairs, they shows a lone pair repulsion as well lone pair bond pair repulsion and bond pair repulsion. So around the element, when there is a lone pair bond pair, there is existence of repulsions between them. So to avoid that repulsions, that orbitals are arranging in a particular way, that gives geometry. So here, due to presence of one lone pair, three bond pairs, this molecule arranging in trigonal pyramidal geometry. So what about the structure here? Here this is a nitrogen which having a lone pair and remaining three bonds are existing like pyramid like this. See here. So simply here we have lone pair bond pair repulsion, lone pair bond pair repulsion. So bond pair repulsion between hydrogen to hydrogen, hydrogen to hydrogen, hydrogen to hydrogen. Again here lone pair bond pair repulsions. So to avoid that repulsions, this molecule arranging in trigonal pyramidal geometry. So when we are taking bond angle between any two hydrogens, example H1, it's H2, this is H3. When you are taking a bond angle between H1 H3 or H3 H2 or H1 H2, we will get 107 degrees. So here we have three nitrogen to hydrogen covalent bonds. Geometry, presence of lone pair, three bond pairs, it become trigonal pyramidal. So I hope you understand well. Hybridization of ammonia, that means hybridization of nitrogen in ammonia molecule. Three covalent bonds which are sigma bonds with one lone pair. Trigonal pyramidal geometry, bond angle is 107 degrees. Here we have lone pair bond pair repulsion, bond pair repulsion. There is no lone pair repulsion because we have only one lone pair and remaining three are bond pairs. So I hope you understand well hybridization of nitrogen in ammonia molecule. So if you like the video, subscribe the channel, share, like, comment and hit the bell icon so that you will get latest video lectures. Thank you.